All right, friends. I wanted to take the time to go over a couple of Go-formative questions that we typically struggle on. Number one is number 6. And this is one of the more common errors when we ask you about velocity and acceleration. So this is number 6, and I'd like to take some time here. So here's the question. A motion of a particle is described by a position function as noted, where t is in seconds and s is in meters. Determine the total distance traveled. So I encourage you to stop the video and try this problem, get stuck or get it, and then check back with the video. Okay. All right. Again, I hope that you have tried this on your own and you're not just watching. Otherwise, you will miss what was hard about this problem. So to start off with, let's make some observations. One is that this is a cubic function, and I know it has a y-intercept at 3. So basically what I know is that it's going to start right there. I know because it's degree 3, it's going to look something like that. And because it's a positive coefficient, it's going to slope in a positive way as opposed to a negative direction. So I know it looks something like that. Okay. There is the chance that it has a different shape, but when we algebraically so what we're guessing here is that there's going to be a slope of 0 there and a slope of 0 there, or there's going to be a turnaround, or there's going to be a rest stop there. So what I'm going to do is see if there is. So I'm going to write this down. And once again, I'm using my trusty mouse rather than a pen. So this is going to be a little messy, but my goal here is to help out just a tiny bit. I think some of us missed class today, and these are questions that we would have gone over had it worked out. Okay, so this is a position graph. So, and remember what we're trying to do is figure out at 8 seconds. So let's say this is 8, and I could be wrong here, but at 8 seconds, what's the total distance traveled? Okay, so what we're going to do is take the derivative, so ds dt of this function here, and that's going to be 3t squared minus 24t plus 45. Oh boy, plus 45. Now, what we're trying to do is figure out when is the velocity 0, and we know that ds dt equals velocity. So if we set velocity equal to 0, and then also we're going to factor this as well. So we're going to factor that. And the reason I'm factoring it is so that I'm going a little bit quick here. Let me slow that down just a little bit. I'm going to scratch that out. I'm going to factor first. So that's going to be t squared minus 8t plus 15. Now I'm going to factor this, and remember this equals 0. And the reason we're factoring this is we're trying to figure out when is the velocity 0, and we're going to use the 0 principle. And so I'm going to factor this, and I think we've all mastered that. T minus 5, t minus 3. So this means at 3 seconds, as well as 5 seconds, we have a slope of 0. So I'm going to guess that right here the slope is 3, and right here the slope, at time 3, the slope is 0. At time 5, the slope is 0. Now we're ready to answer the question. And the question said, what's the total distance traveled after 8 seconds? The common error is to put 8 into this equation here and say you're done. Remember, that would just be its position. But we can see that we started at this distance and we went to the top, then we went to there, and then we did to there. So hopefully you can see there's 3 pieces that we needed to add. And if we take a look at this on Desmos, here's what the graph looks like. And I can see here that we have, we have a high point, a low point, and notice the scale could be a bit off, and there's at 8 seconds. So it started at a height of 3 at 0.3. Time 0 is a height of 3. I will show you algebraically how we find these points, but then it went to that, to a height of 57, then it went down to a height of 53, and then it went back up. So when in doubt, put your graph into Desmos so that you can have a sense of what it looks like, okay? So what we're gonna do, hopefully I can get my pen back. Oh, great. Okay, there's the pen, perfect. Okay, so we're going to use the beautiful color blue here. So what we're going to do is we're going to put at time 0, we're at a height of 3. And then at time 3, when I put 3 into this equation here, when I put 3 in there, S will equal 57. Okay, so that will be 3 comma 57. When I put 5 in, it will be 5 comma 53. And when I put 8 in, it's going to be 8 comma 107. So then you've got to ask, what do we have? Well, what we did is we went from a height of 3 to a height of 57. So that equals 54. There's a gap of 54 between there. And then we went from 57 to 53. And the gap between those two is 4. And then we went from 53 to a gap of 107, which is 54. Okay, and so if we added up piece 1, 2, and 3, we will get the correct answer there, which would be the total distance traveled. And remember, the common error here would be to put 8 in and say that we've traveled a total distance of 107. What's true is we're 107 away from 0. That's what we are, but that's not how far we've gone. For example, if we had something that went up, down, 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 we could say that if this represents height, we started on the ground and we ended on the ground and say we didn't go anywhere. But we can see there's lots of movement there. The other common error there happens right here. Rather than seeing the gap between 3 and 57, we say that the gap is just 57. In other words, start at 0. So again, what's really important here from your curricular competencies, and this would be 1B, 3D, and probably 4B, is to visualize in your mind, and then we need to put it onto paper. We need to model the graph, and we're going to be estimating here to an extent. And then we're going to label it really clearly with our y-intercept at 3. It's going to go up, down, label these points, and then think about what's happening. So I think you'd agree, if you've tried this question, you may have made a silly mistake, okay? And that would be something that you could reflect on and maybe even put that in your digital portfolio. Many people might not have started at 3, or many people might have put 107 in and go, oh, there's a difference between total distance and position, or total distance and distance. So it's the total distance. So we're going to leave that as our first clip here.